Hi, welcome back to the Kids Book of Weather Forecasting. This will be Chapter 3, The Energetic Sun. It will be in two parts because the video was too long to upload last time, so there will be two parts to this chapter. The energetic sun. So what's the fuel that powers this big weather machine? The sun. Without the sun, there would be no weather because everything would be frozen. The sun's energy doesn't warm the earth, its atmosphere evenly, however. Clouds can block the sun in one place while it shines brightly a few miles away. For example, ice and snow reflect the sun's heat back into space, while areas of bare soil soak up the heat. These different locations of heat and cold are what make temperature, air pressure, wind speed, cloud formation, in other words, the weather, change from day to day in most parts of the world. Forecasters study these differences in the amount of heat Earth receives to determine how strong the storms and other weather systems will be. Fuel from far away. The sun sends enormous amounts of energy out into space in every direction, but we're so many millions of miles away, we get only a tiny, tiny amount of it. The sun's energy is so great, however, that even the small amount that reaches Earth is more energy than we use in all the world's cars, houses, and factories combined. Forecasters getting it right rules. Sunshine is very important to air temperature. In the summer, the temperature of a cloudy, rainy day may be cool, even though the barometer is low, indicating that the air is warm and light. Sunny day, sunny mood. Does a beautiful sunny day make your spirits soar? How about a dark winter day? Does it make you feel as gloomy as the weather? As you record weather conditions in your log, keep track of your moods also. Do you notice any mood patterns? Now try tracking your parents' moods and see if they change with the weather. It will help you choose just the right time to ask about getting that new puppy. Be a meteorologist. Taking the temperature. Phew, it's hot. Brr, I'm chilly. Temperature is probably the weather condition we respond to the most frequently. It is also one of the easiest weather measurements to record accurately at home. We measure the temperature of the air around us using a thermometer that reads in degrees Fahrenheit or Celsius. See page 35. You may already have an outdoor thermometer at home. If not, a small portable one is great, very inexpensive at a hardware store, because you can compare reading between sunny and shady locations. Record your daily readings in your weather log, below the barometer readings. If possible, record the temperature early in the day, as close to sunrise as possible, and again in the afternoon around 2:30 p.m. in the winter and around 4 p.m. in the summer. These readings will be close to the lowest and highest temperatures for each day. After recording your temperatures for a week or more, can you see the relationship between higher and lower barometric pressure and temperature? Quick take forecasts. 1. It's a cloudy winter morning and the barometer is rising. Do you forecast warmer or colder weather for the afternoon? Answer. Cold weather is on the way because the rising barometer means heavier, colder air is moving in. There is no sunshine to counter the effect of the cold air. Number 2. It's 10 a.m. Your thermometer reads 55 degrees Fahrenheit. The barometric pressure is rising and the sun is shining brightly. You wonder if you'll be able to fly your kite this afternoon, or will your rain ruin your plans? Answer. 2. As the day goes on, the sun will warm the chilly air and the high pressure will keep the rain away. It should be a great afternoon for kite flying. Fahrenheit and Celsius. Celsius is the standard form of measurement used worldwide by scientists, as well as in most countries for everyday use. In 1742, Anders Celsius, a Swedish astronomer, developed the following temperature scale. The temperature at which fresh water freezes is called 0 degrees Celsius, and the point at which it boils is called 100 degrees Celsius. Then he divided that range into equal number of degrees. This scale is named after him, and it is also called centigrade. Centi means 100. Fahrenheit is another temperature scale still commonly used in the United States. In 1714, the Polish scientist Gabriel Fahrenheit made the first mercury thermometer using this measurement scale. The point where a mixture of water and alcohol freezes is 0 degrees Fahrenheit. The point where fresh water freezes is 32 degrees Fahrenheit, and the point where it boils is 212 degrees Fahrenheit. Calling all math wizards. Here's how to change degrees Celsius to degrees Fahrenheit. Multiply the temperature in Celsius by 9, divide the answer by 5, and add 32. So when the Celsius thermometer reads 33 degrees, what's the Fahrenheit temperature? Answer: 33 times 9 equals 297. 297 divided by 5 is 59. Round to the nearest degree. 59 plus 32 equals 91 degrees Fahrenheit. Woo! It's a hot day. So subtract. To go the other way, just reverse the steps. Subtract 32 from the temperature in Fahrenheit, multiply by 5, divide by 9. Need an answer quick? Here's a shortcut. Here's how to estimate. Negative 10 degrees Celsius equals 15 degrees Fahrenheit. Really, 14 degrees Fahrenheit. 0 degrees Celsius is 30 degrees Fahrenheit. Really, 32 degrees Fahrenheit. 10 degrees Celsius equals 50 degrees Fahrenheit. 20 degrees Celsius equals 70 degrees Fahrenheit, really 68 degrees Fahrenheit. 30 degrees Celsius equals 85 degrees Fahrenheit, really 86 degrees Fahrenheit. 2. So if it is 5 degrees Celsius, it is how many degrees Fahrenheit? Answer: you would estimate 40 degrees Fahrenheit. 5 degrees Celsius is halfway between 0 degrees and 10 degrees Celsius, so your answer is 40 degrees Fahrenheit. Halfway between 30 degrees and 50 degrees Fahrenheit, if you calculated the answer, it would be 41 degrees Fahrenheit. Pretty close. Be a meteorologist. Average highs and lows. As you follow your temperatures for 1 or 2 weeks, you are building an important forecasting tool. Forecasters know that the temperature rises and falls about the same amount every day. It changes slightly, of course, depending on how much sun is shining or whether a warm or cold wind is blowing, but it is still very helpful measurement to track. How can you figure out the temperature rise and fall for your location? You'll need to do a little math using the readings in your weather log. 1. Add up all the daily high temperatures, then divide by the number of days. If you add up 10 days of temperatures, then divide by 10. The answer is the average high temperature for that period of time. Now do the same with the daily low temperatures to get the average low temperature. Subtract the average low from the average high. This is the average amount the temperature rises and falls each day. Forecasters getting it right rules. The difference between the highest and the lowest temperatures of the day in any specific place is always about the same during each particular season, spring, summer, fall, or winter. This figure predicts how the temperature will change during the day. There's the math. Quick take forecasts. 1. Your average rise in the temperature is 20 degrees Fahrenheit, 11 degrees Celsius. This morning the temperature is 40 degrees Fahrenheit, 4 degrees Celsius. What do you forecast the afternoon temperature will be? Answer: 1. This afternoon the temperature will be 60 degrees Fahrenheit. 40 degrees Fahrenheit is the current temperature, plus 20 degrees Fahrenheit, which is the average daily rise, equals 60 degrees Fahrenheit afternoon temperature. Number 2. This morning's temperature is 50 degrees Fahrenheit, and you forecast the afternoon temperature to be 60 degrees Fahrenheit. On your barometer, the air pressure is falling. Will tomorrow be warmer or colder? Answer: 2. Things should warm up even more tomorrow because falling air pressure indicates that warmer air is moving toward the region. However, clouds and rain could affect your forecast. No thermometer? Just use a cricket. Count the number of times a cricket chirps in a 13-second period, then add 40. That number will come close to the actual temperature in degrees Fahrenheit most of the time. Really, try it. We will return and do the second part.